most probable explanation is that the heat pump is engineered to function on a 277-volt system, which is frequently encountered in commercial and industrial structures. The 267 volts rating accommodates a 10% voltage drop, which represents the maximum permissible voltage drop according to the National Electrical Code (NEC) for branch circuits. This voltage drop is essential to guarantee the heat pump receives the correct voltage for proper operation. If the voltage drop surpasses the limit, the heat pump's operational capacity might be compromised, or it could potentially cease functioning altogether. Furthermore, the 267 volts rating could enable the heat pump's utilization within a 240-volt system, often seen in residential buildings. However, it's vital to acknowledge that the heat pump won't attain its peak performance levels when operating on a 240-volt system. Consider a table elucidating the connection between a heat pump's voltage rating and the voltage of its installed system. Firstly, a 267 volts heat pump corresponds to a 277 volts system. Secondly, a 267 volts heat pump can function on a 240 volts system, albeit with diminished capacity. It is paramount to recognize that a heat pump's voltage rating differs from its operating voltage. The operating voltage denotes the voltage needed to power the compressor, the key component responsible for circulating refrigerant within the system. Usually, a heat pump's operating voltage is less than its voltage rating. As an instance, a heat pump marked for 267 volts could possess an operating voltage of 208 volts. Always refer to the manufacturer's guidelines specific to the heat pump model being installed to ascertain its precise operating voltage. Now let's delve into the NEC stance on voltage drop. The NEC addresses voltage drop in branch circuits and feeders to ensure efficient and safe operation of electrical equipment. While the NEC doesn't mandate a specific voltage drop percentage, it provides recommendations in informational notes. These notes suggest a maximum voltage drop of 3% for branch circuits and 5% for feeders, resulting in a total voltage drop of 5% from the service entrance to the farthest point of utilization. The recommendation for a 3% voltage drop in branch circuits is found in NEC section 210.19. A1 Informational Note Number 1. Similarly, the recommendation for a 5% voltage drop in feeders is found in NEC section 215.2. A3 Informational Note Number 1. It's important to distinguish between mandatory rules and informational notes. The NEC consists of enforceable rules and non-enforceable informational notes. The recommendations for voltage drop are presented as informational notes, indicating they are guidelines rather than strict requirements. However, adhering to these recommendations is generally considered good practice. Excessive voltage drop can lead to several issues. Equipment may not operate correctly, lights may dim, and motors may overheat. Moreover, voltage drop results in wasted energy, increasing operating costs. Consequently, minimizing voltage drop is beneficial for both equipment performance and energy efficiency. Calculating voltage drop involves several factors, including the conductor's length, size, material, and the current flowing through it. The formula for calculating voltage drop is voltage drop equals 2 times the length of the conductor in feet times the current in amps times the impedance of the conductor in ohms per foot divided by 1000. Selecting appropriately sized conductors is crucial to minimize voltage drop. Larger conductors have lower resistance, resulting in less voltage drop. The NEC provides tables to assist in determining the appropriate conductor size based on the expected current and allowable voltage drop. These tables, such as those found in NEC Article 310.15, factor in the conductor's ampacity and insulation type. Considering ambient temperature and conductor bundling is also important when selecting conductor sizes. High ambient temperatures and bundling can reduce a conductor's ampacity, requiring a larger conductor to maintain the desired voltage drop. Voltage drop calculation should be performed under the expected load conditions. The load is the amount of electrical power being consumed by the equipment connected to the circuit. Different types of loads have different characteristics. Resistive loads, such as heaters, draw a constant current. Inductive loads, such as motors, draw a higher current when starting. Capacitive loads, such as capacitors, can cause voltage fluctuations. It's also important to consider the power factor of the load. Power factor is the ratio of real power to apparent power. A low power factor can increase voltage drop. Power factor correction can be used to improve the power factor and reduce voltage drop. This typically involves adding capacitors to the circuit. In long branch circuits or feeders, it may be necessary to increase the conductor size to compensate for voltage drop. This is especially important for circuits that supply sensitive electronic equipment. Sensitive electronic equipment can be damaged by voltage fluctuations. Voltage regulators can be used to maintain a constant voltage to sensitive electronic equipment. Voltage regulators are devices that automatically adjust the voltage to compensate for voltage fluctuations. They are commonly used in hospitals, data centers, and other facilities where reliable power is critical. In addition to conductor size, the type of wiring method used can also affect voltage drop. Wiring methods with lower impedance will have less voltage drop. Examples of wiring methods with lower impedance include conduit and cable tray. The NEC specifies the allowable wiring methods for different types of occupancies. The NEC also specifies the requirements for grounding and bonding. Grounding and bonding are essential for safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. Bonding connects all metal parts of the electrical system together, which helps to prevent voltage differences between the metal parts. This reduces the risk of electric shock. The NEC also covers overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect the electrical system from overloads and short circuits. Overloads occur when the current in a circuit exceeds the ampacity of the conductors. Short circuits occur when there is a direct connection between two conductors of different voltage. Overcurrent protection devices will trip or blow when an overload or short circuit occurs, interrupting the flow of current and preventing damage to the electrical system. Regular maintenance and inspection of electrical systems is essential to ensure safety and reliability. Maintenance should include checking connections, tightening loose screws, and replacing worn or damaged components. Inspections should be performed by qualified electrical professionals. Inspections can identify potential problems before they cause a failure. Here are some additional considerations for heat pump installations. Heat pumps are complex electrical devices that require careful installation and maintenance. Heat pumps should be installed by qualified HVAC technicians. Heat pumps should be sized correctly for the building. An undersized heat pump will not be able to heat or cool the building adequately. An oversized heat pump will cycle on and off frequently, which can reduce its efficiency and lifespan. Heat pumps should be located in a well-ventilated area. This will help to prevent the heat pump from overheating. Heat pumps should be protected from the weather. This will help to prevent damage to the heat pump. Heat pumps should be inspected and maintained regularly. This will help to ensure that the heat pump is operating efficiently and safely. The NEC provides specific requirements for heat pump installations. These requirements cover topics such as disconnecting means, overcurrent protection, and grounding. It is important to follow the NEC requirements when installing a heat pump. Ignoring these requirements can create a safety hazard. When working with electrical systems, always prioritize safety. Turn off the power before working on any electrical equipment. Use appropriate personal protective equipment, such as gloves and safety glasses. If you are not qualified to work on electrical equipment, hire a qualified electrical professional. Electrical work can be dangerous. It is important to take the necessary precautions to protect yourself and others. The information provided is for general guidance only. Always consult with a qualified electrical professional for specific advice. The NEC is a complex document. It is important to understand the NEC requirements before performing any electrical work. Many online resources are available to help you understand the NEC. You can also take classes on the NEC. These classes are offered by community colleges, trade schools, and electrical contractors. Staying up to date on the NEC is important for electrical professionals. The NEC is updated every 3 years. It is important to be aware of the latest changes to the NEC. The NEC is a valuable resource for electrical safety. By following the NEC requirements, you can help to protect yourself and others from electrical hazards. In summary, a 267 volts rating on a heat pump likely indicates its compatibility with a 277 volt system while accounting for potential voltage drop. It might also function on a 240 volt system of reduced capacity. Always consult the manufacturer's documentation for specific operating voltage details and adhere to NEC guidelines for safe and efficient installation. Remember to prioritize safety when working with electrical systems and consult with qualified professionals when needed.